Hi everyone, welcome to my YouTube channel Networking Made Easy by T.S. Srinivas. So in continuation with our line coding schemes, so the last session you have seen what are the different types of line coding schemes are available with us. So today we will see another technique in PCM, call it as a scrambling technique actually. Okay, so why this particular thing is required is because, see, we have seen many schemes as such. So out of all, if you see the NRZ is the most simplest form of line coding. Okay, but as we have seen certain qualities required for the line coding schemes, that is there should be a good synchronization technique should be adopted, means that option should be available with the scheme, and there should not be any DC component as such, and error detection capability also should be there. Since these things are missing in the NRZ, but it's a simple scheme, so that's why that particular technique is generally used for digital magnetic recording, small activity. So this technique is being used. But at the same time, we have seen another scheme called biphase Manchester and differential Manchester. It is having extraordinary, means all the things have been justified, like synchronization is excellent. Okay, there is no DC component, as a lot of signal changes are there, and error detection capability is also there. But as you've seen, this type of thing, if you want to, for long distance transmission, the bandwidth requirement is high and the cost of the transmitter system will be more actually. So that is the reason that also is being adopted in the local area networks. Okay, so within the small distances, this particular scheme is adopted. Okay, so then there should be some method for long distance communication. Okay, so we have seen another very important scheme, that is alternate mark inversion. Alternate mark inversion. So in this particular technique, we have seen that means three levels have been used, the positive and negative as well as zero. So zero is representing only zero voltage represents zero, but both the positive and negative represents 1. Okay, the positive and one alternately it keeps changing. So just to see why it is being done in the AMI like this is, if there is any continuous ones are there, continuous sequence of ones are there, so we have seen in the NRZ there will be a DC component. To avoid this particular thing, so this pulses are alternately changing its polarity. So the consecutive ones problem is solved in the AMI, but still one problem is remaining, that is consecutive zeros. Okay, if there is a consecutive zeros are there, there is no solution. So what is the trouble if the consecutive zeros are there? So definitely what happens is, the receiver at some stage, if it is synchronization is missing, it is unable to reproduce the original signal, original bits. Okay, so this particular thing we call it as a baseline wandering, because most of the times it is zero, so some noise is also overlapping onto it, so it is wandering at that particular place. Okay, so otherwise that particular technique is good. AMI scheme is good as far as the long distance transmission is concerned, because it consumes less bandwidth. So in order to have some solution for the consecutive zeros, this particular scheme has come up. So that is nothing but the scrambling technique. So in this technique, we have two schemes, that is HDB3. It stands for high density bipolar 3 zeros. High density bipolar 3 zeros. So what it does is, in this particular thing, the consecutive four zeros are there. So we are taking care of it. Okay, we are replacing with some bits. Okay, so what is the thing kept in mind is, okay, because consecutive zeros means DC component is there. So to avoid that, at the same time we want to put some synchronization capability also, and as well as error detection capability also. So keeping these three things in mind, these schemes have been decided. Okay, So now let us see how this is being implemented. Okay, so we have taken a series of bits like this. Okay, you find here the consecutive 4 zeros are there. Here you have consecutive 8 zeros are there. Again 4 zeros are there. So let us see how to implement this particular scheme. Okay, so transmitter is doing it is introducing some codes into this. So receiver is also aware about this particular thing. So whenever it is finding this kind of codes, it understands. So there is a consecutive 4 zeros are there. This code is to be replaced back again to the zeros. So that understanding is there between the transmitter and the receiver. Okay. Now let us see how this scheme is working. Okay. See, just pay little attention. There will not be any confusion in this particular scheme. Okay. Now what has been told here is, okay, the number of bipolar ones since the last substitution. Since last substitution means bipolar ones in the sense, see, whenever there is a 1, there is a pulse. Okay. So you count number of ones from the last substitution. Okay. If it is even, you replace all 4 zeros with this particular code. What is that code? B00V. Okay. Now it's a new thing, B00V. Then now the question is, what is B and what is V? Okay. Now see here, B stands for valid bipolar. So B stands for valid bipolar. Okay. So what V stands for? Okay, what do you mean by valid bipolar? Valid bipolar in the sense, see, you know in AMI scheme what is happening. Suppose if the last polarity is positive, next if you want to put a pulse, it should be negative. Okay, so that is what is the valid bipolar technique. Okay, scheme, whatever it is. Okay, so it follows, suppose earlier pulse is negative, so whatever you are replacing the pulse, that should be positive. If earlier pulse is positive, whatever you are replacing the next pulse should be negative. So that is what it is, following the rule of the AMI. But V stands violation. It's bipolar violation. So if earlier pulse is positive, the next pulse what you are going to put is again positive, means you are violating the rule of the AMI. Similarly, if the pulse is negative, you are replacing with negative. So again you are violating here. Okay. So when you are replacing this particular code from the last transition, if the number of ones is even, then the 4 zeros is replaced with this. Okay. Now if it is odd, it should be replaced with this. That is, all the 4 zeros will be replaced with 3 zeros followed by violation. Okay. So you just see why this particular 2 schemes, very carefully it has been designed. So see, every time after doing this, what you can observe is, after the replacement, if you count the number of replacements, pulses you have made, so that will be in the even number. Okay, even number. So that has been taken care. And at the same time, you have to ensure that successive violations will be alternating. Okay. So it is so carefully seen that, see, ultimately our objective should be achieved, isn't it? If all the pulses are in one direction, okay, then again there will be an issue of DC component. Okay. So that's the reason it has been very carefully taken care that alternate violation pulses also will be alternate. Okay. So now that also we'll see. Okay. And another very important thing is, see, after following the rules, at some particular time you may be finding, see, if these bits are originally replaced with AMI scheme, okay, you find that one may be positive or maybe negative, whatever the case may be, and after implementing the scheme, you find it may not be matching with the AMI scheme. So we no need to worry here, because receiver understands, because automatically the AMI rule is applicable after implementing the codes. So this you should be, because generally you may be in confusion, but after putting the codes earlier this was positive, now it is becoming negative. Okay, so there should not be any confusion about this. Okay, now coming back to the implementation part, now see, we are starting from here. Okay, now we don't know what is means. You just imagine from here you are counting ones. It's 2 ones. Then what we need to do is, it's even, 2 is even. So we have to replace with this particular code. So that is nothing but B00V. Fine. So this is over. Then again after 1, now 1 is there. After 1 again you find another consecutive 4 zeros. Then what to do? So after the last violation, how many ones are there? Only 1. So it's odd. So what has to be done? It is to be replaced with this particular code. Okay. Now it is replaced with 000V. Okay. Now see, after the violation, is there anyone? No one. No one means 0. 0 means even. Okay. Now again replace with B00V. So naturally it is again 0. Okay. Now again ones have come. So after the last violation again you find 2 ones are there. It's even. So this has to be replaced with B00V. That's it. See, once you have done this means your job is done. So after making the pulses is not a difficult job at all. Okay. Now here again, so what should be this pulse? Positive or negative? Okay. It could be anything, isn't it? So it depends upon the earlier case. Earlier if it was negative, it will be positive. Okay. Now let us assume it is positive here. Okay. Now since again 1 is there, so as per AMI this is negative. Okay. Now what B says? It has to follow the AMI rule. So what rule says that if it is negative, then this has to be positive. Fine. Now 2 zeros. No pulses. It continues up to here. Okay. Then what? V. V means violation. Violation means this. Same thing should repeat. It's done. Okay. Now again what? 1. So AMI rule. So negative. Fine. Now what next? 3 zeros. Comes up to here. Now again violation. Violating what? This. Earlier it was negative. So again it is violating it. So it is making negative. Okay. Now fine. So now as we are saying, this is B. So B means it should follow AMI rule. So it is positive again. So it continues again 2 zeros. Then violation. So violation means positive. Okay. Now again 0. Fine. So now again normal ones are there. So what we have to do? It has to follow AMI rule. So this is again negative. Again it is positive here. Fine. So after the last violation, what is this? How many ones are there? 2 ones. So again it is replaced with even. So naturally B is there. B is there means it has to follow AMI. So come back. Fine. Now again 2 zeros. Then again violation. That's it. So this is how this stream of bits is represented in this particular code form. This particular technique we call as a scram or block code, because you are introducing some codes. Okay. If the receiver is finding this kinds of codes available in the stream, so it understands that these things should be replaced with zeros. That's it. Okay. Now let us see here. We are told that are we maintaining even number of non-zeros or not? That you see here. See, already these two are even. Even if you count also 1, 2 up to the violation, 1, 2, 3, 4 even number. So after this again 1, 2 even. Okay. 1, 2, 3, 4. It's even. Okay. So from here, from the last violation to the next violation, it is even number. Then again after this 1, 2, 3, 4, it's even. So this is taken care. So again, what is next? Ensure successive violation of alternate polarity. Let us see. Now here it is one violation, and here again it is another violation, here another violation, and here again another violation. So here it is positive, this one it is next violation is negative, again it is positive, again here it is negative. See, both the things are taken care. Okay. So another thing I was just telling that why we should not bother. Suppose for example, in the normal AMI scheme, if you would have converted, what could be the situation? This should have been a positive pulse. Okay, this should have been a positive pulse. This is a minus. Then all the zeros could have been there. Okay. Now here for next one, it should have been positive, normal AMI. But here it is negative. So that is what I was telling. You should not get confused with this. Because after implementing of the scheme, the next ones will automatically follow the AMI rule. So that is it. Okay. So this is the only simple logic you have to understand. That is, only count the number of ones. If it is even, replace with that code. If it is odd, replace with this code. That's it. Okay. So if you want to further make it easier, okay, it could be that way also. Suppose if it is even, you may extend this formula, and if it is negative, then you may be replacing with plus 0, 0 plus, or if it is positive, minus 0, 0 minus. Okay, don't go to that extent. Okay, you will get confused. If you are remembering this, see, B, B means follow the AMI rule. V means what? Okay, not follow the AMI rule, that's it. Just opposite. So if you remember this, just simply replace with this codes, that's it. Count the ones. If it is even, replace this. Odd, replace with this. That's it. Okay. So I am sure you might have understood this high density bipolar 3 zeros code. Okay. So the coming back to another, see, this is another scheme following in the same scrambling technique. Okay. So I will let you know why these two different. See, this particular scheme, what is there? It is followed in the European countries. Okay, that is, even India also always follows the technology of the European technology. So even in the PCM, in India also we are implementing this particular code in the long distance transmission. Okay, so whereas this particular scheme, okay, bipolar with 8-0 substitution, that is B8ZS. So this is followed in North America. Okay. Anyway, we will be discussing about this kind of differences in the PCM when we go for the time division multiplexing. So there also the multiplexing technique also differing for North America and the Europe. Okay, because due to some reasons in the PCM, some standards that particular time could not be developed, could not be adopted. So certain countries have adopted their own different schemes. Okay, so that we'll discuss more in the TDM, time division multiplexing. Okay. Now what is being done, because I have taken the same code here, this particular B8ZS is very simple. Okay, what simply you have to do is all the consecutive 8s should be replaced with this particular code. Okay, all the consecutive 8 zeros should be replaced with this. That is 3 zeros followed by a violation. Okay, then comes that is B, valid bipolar, then 0 VB, that's it. Just remember this code, your problem is solved. Very simple. Okay, so wherever 8 zeros are there, then only it is applicable. 4 zeros definitely it will ignore. Okay, 4 zeros it will not bother because there is no provision. Only it is looking for 8 zeros. Okay, now here, or what we see here, 4 zeros are there, that's it, cannot do. Now here we have 8 zeros, 4 zeros, 8 zeros. So what you have to do, it has to be replaced with 0, 0 with violation, and then comes B, 0, 0, V and B, that's it. So it's a 90, it will continue like that. Okay. So what we have to do is, so this 8 zeros is replaced with this particular code as it was told. Okay. So what actually you remember is this 3 zeros, V, B0, VB, that's it. Okay. Now if you are drawing the pulses, say again we'll assume the previous one is positive here. Okay, as per AMI, this is minus. So 4 zeros, you cannot do anything. It continues. Now as per AMI, this is positive. Okay. Now it is replaced with 3 zeros. Now you have to violate. Okay. So what has to be violated? Since this is positive, instead of going negative, again it has to be positive. Okay. Next again what? We have to follow the AMI rule. So this will be negative. Okay. 0. Then one violation. So again this is negative. Then again follow the AMI rule. That's it. So 0 again. So next standard is ones have to follow the AMI rule. So this will be negative, then positive, then finally again 4 zeros. We cannot do anything in this scheme. So this continues. Okay. So this is another simple scrambling technique. Only in this case is all the 8 zeros are replaced with this particular code. Okay. So this was in continuation with our last lecture of line coding techniques. Okay. So as we all, so with this, you might have understood all the different line coding schemes are available with us. Fine. So further to this, now what you have done up to, we have achieved up to encoding. Fine. All the digital stream of pulses which has been quantized has been put into the signal form. Now what next? Okay. So in order to transmit to the long distance communication, so what we need to do is we have to adopt some modulation techniques. Okay. So in our next lecture, let us see how these pulses are using different digital pulses are being implemented by using different modulation techniques. Okay. So fine. So once again the same request. See if you are following, that's very good. And if you are having any doubts or you want some improvement in this or any new topics, you can write your comments in the comments box. Okay. And another request, please subscribe to my channel. Okay. So this is very primary thing, isn't it? See, almost every alternate day or within 2 days, I am uploading a new topic. Okay. So if you are subscribing, definitely you are going to benefit. Okay. This particular new video is readily available for your knowledge. Okay. At the same time, like it and share to many of your friends. Okay. So that's how I can put a lot of interest. If that is the case, many people are watching this particular videos. Definitely I will have a lot of interest. So I'll put more content in the videos. Okay. Thank you for watching my video. Let us see in the next session. Bye.